What do you get for this Dom? Why 2, Seamus? Why does it make sense? It, it just kind of seems like that's where we go, doesn't it? But you answered it correctly. Doesn't it look like it should be y equals 2? Yes, it does. Well, it turns out it's not 2. But that doesn't make you wrong. That doesn't make you wrong at all. What Seamus just gave me was the limit of this. Dang it. I had a really good rhythm going. I'm going to undo everything I've done and completely say it all again. It turns out this was not 2, but that doesn't make you wrong. It's hard to do with as much gusto the second time. What you've given me is actually the limit of this function as x approaches 2. That's what you told me. We're going to be dealing with limits for the next few days. All limits are context clues from a graph. You're like, hey, that looks like where it's going. That must be where it goes. That's a limit. That's all a limit is. People get so confused about limits. Like, I don't understand what I'm looking for. Well, because here's the thing. If I hadn't covered that up, and I said, what does this function equal? Now, what does it actually equal at 2? 1. The actual point is at 1. But if I said, what is the limit as x approaches 2, that means, if you weren't looking at that, what does it make all the sense in the world that that would be going to? 2. So, that is the limit. As x approaches 2 of the function f of x, the limit equals 2, even though the actual function at that point is 1. Any questions about the DOM? Although that's essentially the lesson, but we'll talk about it some more. All right, start up some notes. 11.1. 11.1. Well, maybe it got mixed in with some other stuff. I guess I'll keep looking. All right. Now, before we actually, you know, we're going to come back to this. Let's just keep going with the graphs. Number 19. Now, unlike the DOM, please notice 19 is a nice continuous function. There's no break. There's no asymptote. There's no hole. Whenever there's no break in the function, then all of its values are going to equal its limits. The only time these two things are going to be different, the actual function value and the limit as x approaches that value, only time those are going to be different is if there's a discontinuity in your function. If there's not, then they're going to be the same. What is f of 3 of this function? Negative 1. What does the function look like it's going to as it approaches 3? Negative 1. Very good. Any questions about why those are the same or how we got those? All right. Now, here. All they're doing here is telling you the window. That's all you need from that. What is the limit as x approaches 2 of that function? Well, look at the function. Think about what we know about asymptotes and discontinuities. What causes something to be discontinuous? What causes something to be impossible in functions? Dividing by 0 and then negative under a radical, right? Remember how in the past we said if neither of the, or trig, I guess. If neither of those two things are happening, it's just going to be continuous? Same kind of thing. If neither of those things are happening, is this going to be like a break anywhere? The answer to that question is no. So, just like the last slide, that means the limit of that function is going to equal the exact point. So to find the limit, all you really have to do is plug in that x value. Well, what's that function going to equal if you plug in 2? Negative 3. 1 minus 4, negative 3. Sure enough, if we follow this thing along in both directions and get closer and closer to 2, it is negative 3. If there's no discontinuity, you can just plug in the value to find the limit. 25. Negative pi over 2. Well, they went by some straight. I don't really know what this interval is. I'm assuming it's 10. I don't have to cut it off. Well, think about it like this. Sine of negative pi over 2. You're going to have to think somewhat about the unit circle. Anybody know their unit circle well enough to answer me what sine of negative pi over 2 would be? Give you a hint. I'll be the unit circle. Okay, here's 0. It goes down, negative pi over 2. Anybody remember what sine of straight down was? Anybody at all? Negative 1, right. Sine of, could just punch the thing into your calculator. Make sure you're in radio mode. Sine negative pi over 2, it existed. It was negative 1. So its limit is going to be negative 1. And I guess that must be it right there. It must be going by pi. If you can punch in the value into your function and it equals, and it doesn't cause any problems, that is your limit. Because there's no discontinuity, so there's really no point to have a limit. But they're just seeing if you know how to find it. Now, here is where limits get interesting. Now, let's not actually look at any of the stuff at the bottom just yet. If I were to cover up everything there, if that was all you had to work with, and I said, what do you think the function is going to be at x equals 2? What would you say? I'm going to call on people because this is zombie land today. Olivia, what do you think this function would equal at x equals 2? Very good. Wish you hadn't said it with so much fear, but you're correct. 4. And that's a perfectly legitimate response. Well, let me move this out of the way. Savannah, now if I said, what do you think the function is going to equal at 2? What do you think it would be? You're right. Which one of them is wrong? You're right, neither of them. Remember how in the DOM, both of the points went to the exact same spot? Well, here, neither of them is wrong, but if they contradict each other, if you look at that function from both directions and they contradict each other, then the overall limit of that function doesn't exist. What Olivia gave me was the left-hand limit. She looked at the function as x approached 2 from the left-hand side, and she did it perfectly correct. She said it's 4. The function getting close to 2 from the left-hand side was 4. Savannah gave me the right-hand function. As x approaches 2 from the positive side, it was 2. And she was right as well. 4, 2. But if these numbers aren't the same, in other words, if they're both going to different places, because now if I said, don't tell me what it equals, what does it look like it's going to equal? There's no way to know, because they're going to different places. So if these two numbers aren't the same, then part C is not going to exist. C and E. It does not exist. What about part D? What's that one? 4. Yeah, it's where the actual enclosed dot is. Notice this one's open, meaning it doesn't exist. So, quick little summary. This one was 4, 2, does not exist, and 4. Questions about where we got any of those answers? Now, rather than draw this whole thing, you could just write in your notes number 27 from the book, and then write down the answers and go back and draw them later if you want to. Okay, let's get crazy. Ooh, 12 of them. That's enough for me to pick on almost half of you. Here we go. Now, it's okay if you're a little hesitant. Take your time. We're learning together. If you get along, it's okay. Who am I going to pick on first? Great. A, what do you think? Let's see. -3 from the left-hand side. 2. Very good. Kaylee. Give you a hint. You can whisper with Greg. Kaylee, what do you think part B would be? You can even help with the answer. Very good. Very good. As it approaches -3 from the left-hand side, +2. As it approaches -3 from the right-hand side, you just follow along the function. It's +2 again. Are these two things the same? Yes. Therefore, the overall limit is also 2. And the actual function value at -3 is also +2 because it's not open or anything. So this was 2. Whoa, 2. Come on, 2 and 2. I thought I'd fix this. It would have been doing so much better. Well, we may just have to talk about these and you write them down on your own. So 2, 2, 2, 2. Part E. Rachel. I sure can. -1 from the left. -1 from the left-hand side. You know, there's a table in front of you that's up and you can see that from okay. Maybe I'll buy some binoculars. -1 from the left-hand side. Here's -1. Coming in from the left. What y value is that approaching? Very good. 4. Well, I'm not going to write it. 4. F. Eeny, meeny, miny. Shelby Emmett. What do you think F is going to be? The limit as x approaches -1 from the right-hand side. Here's -1. As it comes in from the right, what y value is it approaching? Up here? Well, it actually comes down. Let me try to blow it up for you. How about this? Or I could just blow it up. Is that better? Okay. -1 from the right-hand side. It is 3. Well, now you can see. Then, what would that make the overall limit? From the left, Rachel said 4. From the right, Shelby said 3. What's that going to make the overall limit? Are those the same? What? Exactly. If they're not the same, it doesn't exist. So the overall limit, part H, I believe it was, or I don't know what it was, G, does not exist. So what does the actual function equal at that point? Jordan, what do you think? What does the actual function equal at -1? Who wants to give it a guess? Josh, what do you think? What does the function equal at -1? Please know I'm not above asking trick questions. 3.5. I figured that you could have it. It actually doesn't exist. If there's no filled in dot, then that point just doesn't exist. It's not there. So, all right. I'm assuming the next one it asked for is +3 since that's where some action is happening. Zach, what do you think the left-hand limit of +3 is? As it comes in from the left. You're correct. Morgan, what do you think the right-hand limit is? Close. It comes all the way down to 2. Sabrina, were those the same? We said it 4 seconds ago. Very good. Yes, they are. So if they're the same, what's the overall limit? Also said it 4 seconds ago. You're not even paying attention.
I was looking at the book.
Austin, what's the overall limit? Close. What? 2. If the two limits are the same, then we can assume, just like Seamus did in the DOM, that our overall limit is 2. Now, Jessica, what is the actual function equal at that point? 1. Very good. So, let's put our confusion into words here. Which part of this lesson is it that's still fuzzy? I'm getting a lot of confused faces when I ask questions to the crowd. Which part of it seems the most confusing? The overall limit? That's an interesting way to word that. Okay. Let's see if I have another drawing example. Oh, wow. We're not ready for that yet. Dang. I guess we're going to have to deal with this one. Okay.
It's not a good idea to try to not confuse the real confusing.
I know. You're right. Bad example. Let's make our own. Okay. Okay. There's a lot of anxiety going around for some reason. So let's make our own example. Let's have our critical points be 1. I've never tried to draw when it was doing this. And -1. All right. So we're going to have this one come. It's going to come in and freeze right there. Then it's going to pick up down here. And it's going to come and again. And it's going to pick up down here. And it's going to come in and again. But then it's going to have a random point up here and just keep going. So here we go, making up our own example. I'll give you a hint. Every answer is going to be 1, -1, 0, or does not exist. Okay. Here we go. E. What is the limit of this function? As x approaches -1 from the left-hand side. Very good. Sarah, what is the limit of this function as x approaches -1 from the right-hand side? Very good. Joey, are those numbers the same? Therefore, the answer to the overall limit is does not exist. Karen, what would my actual function value be at -1? I'm sorry, I can't hear mumbles. Come on, lady. What? Very good. At -1, the actual function equals, because that's the filled-in dot. Okay, dang it, we're going to get everybody. Holly, as x approaches 0 from the left, what's our function? Very good. Colton, as x approaches 0 from the right, what's our function? Okay, we're kind of rolling now. Alyssa, what is the overall function at 0? I mean, what is the overall limit at 0? C. Very good. Shelby, what is the actual function equal at 0? Very good. All right. That's like 18 right answers in a row. Jared, what does the limit as x... Start over. What is the limit of this function as it approaches +1 from the left? It is. Sabrina, what is the limit of this function as x approaches +1 from the right? Very good. Zach, are those the same? Yes. Yes. Therefore, our overall limit is also very good. Awesome. We're almost done. Melinda, what is the actual function value at f(1)? Close. The actual function, it's kind of hard to see. I know I'm going to put a little bitty dot up here. The limit would be 0. The actual function value would be +1. Okay, I'm feeling better about this. So now we know how to read them on a graph. What about if we read them on paper, like with actual equations? It's actually easier, believe it or not. Yes, it is. Let's go all the way back to the beginning of the presentation. Now, here, this is an extremely obvious example. Okay, they're just trying to get you to notice. We are looking for what this function can equal as x approaches 2. Okay? And here's how you can do all of them today. Let's say, well, we'll do it for this one, I guess. Actually, here we go. We're going to do this on our calculators together. Because you can do all of the ones without a graph, you can do on your calculators, and I won't be upset. In fact, I'm encouraging you to do that. Okay. On. First thing you want to do, graph your function. 2x squared. Graph. Okay. Now, first thing you need to do, punch in your function. Trace. I want to know what this thing equals at 2. Enter. Look at that spot. Is it continuous? Does the function just keep going, and do we actually have a y value? Well, that's probably because your window's different. Does it still look like a loop? Okay. First off, when we plug in 2, do we have an actual y value? Is there a number where my finger is? Yes. Okay. Look at the actual graph. Does it look like it skips, or does it look pretty continuous? It looks continuous. This is one of those examples that didn't have a break, and we could have known that. There's no denominator. There's no radical. Nothing's going to cause that to be discontinuous. So that's why the limit of this function equals the exact point. But let's say for some weird reason, our calculator had not given us this. It said y equals Tue Nov. How could we find the limit? Well, how did we do it on the picture? Didn't we take our fingers and trace it really, really close? So that's what they're saying. They're saying take points closer and closer and closer to our value from either side. What's a number just slightly less than 2? How about 1.99999? What's a number just slightly greater than 2? 2.000001. Trace those values and you get these. Do these two numbers look like they are both approaching the same number? Yes, and what is that number? 8. And that is your limit. If, what? Yes. Yes. Now for 1 and 3, they've spared you using the calculator, and they've done it for you. Even if you have no idea what this looks like, look at its XY chart. Look at its XY chart. We're finding the limit as x approaches 0. As x approaches 0. Well, they've already broken it down for you. As x approaches 0 from the left, and as x approaches 0 from the right, are they going to the same number? What does it look like that number would be? In the whole number of words, does it look like that's approaching some actual 3? And that would be your limit. So let's actually trace this on the calculator and see it for ourselves. Now, anytime using trig, probably want to be in radian mode. Because these are the only two that are going to do it like that. So, 1 equals sine, what? Yes, divided by x. Graph. Wow. We got it. Now, because I know the amplitude of this trig function to be 1, I know that I don't need to go higher than -1 or 1, 1. Oh, that's x anyway, isn't it? Man, I'm struggling. To the best of us. Okay. Graph. There's a little more zoomed in version. Now, I want to know, hey, what does this thing equal at 0? Nothing. So, how are we going to find our limit? Trace values close to 0. What is a number really, really close to 0, but slightly less than? Negative. Yeah, this one they gave it to us. And I say, just go straight to a number really close, like -0.00000001. Enter. Ooh, if you go small enough, it'll just flat out tell you because it's getting tired of your games. It's saying, hey, dude, it's 3. Okay? What's a number greater than that? We need to make sure they're going to the same thing. What's a number slightly greater than 0? 0.00000001. Dude, serious. Aw. What happened? I must have hit the wrong thing. Trace. What is going on? I made it mad. I'm sorry I made you mad, sir. I take it back. You know what? Maybe if I actually go up. There we go. Let's try this. Trace. try this again. 0.000001. There we go. 3. Are those numbers the same? Then that is your limit. If they are different, not your limit. And they will be different sometimes. It won't always be a whole number. Sometimes it'll be a fourth or a fifth or a third, but etc. That's how you're going to do everything without a graph today. Now, like I said, if you can plug it in and it equals something, that's all you have to do. If we plug 2 into the top equation, what does that function equal? 20, meaning that function's not discontinuous at that point. So that means our limit will also be 20. Our limit is only going to differ from what the function equals if it's discontinuous. Now, number 7, what would cause that function to be discontinuous? A 2. If this limit went to 2, then we'd have some work to do. But it doesn't. If we plug in 3, what does that make this function equal? So that's the answer, 1. If you plug 0 into number 9, what does it equal? 0 over 1, which equals 0. We plug negative 2. It's negative 8 plus 8 over negative 2 plus 2. Dun, aw, dun, 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 dun. You get 0 over 0, means you have to consult the calculator. Sure. So, here we go. Numerator. X cubed plus 8 divided by x plus 2. It's way up there. Let me just do a standard window real quick. There we go. So, trace negative 2. Now, we already know it doesn't exist, but I just want to make sure we did it right, and we did. Our calculator's saying, hey, bro, there ain't no point there. So, trace. What is a number ever so slightly less than negative 2? That's actually slightly greater, but that's where we're going next. Negative 2.0001. That's a number ever so slightly less than negative 2. Enter. It says 12. Interesting. Here we go again. What about a number slightly greater than negative 2? Negative 1.999999. Enter. Also 12. If they're the same, then that's your limit. Then your limit does not exist. Excellent question. So the limit is 12. Now, if you are an Algebra 2 ninja, and you're like, hey, dude, difference of 2, or the sum of 2 cubes, and I think that's like x, man, who here is good at this stuff? Isn't it like x plus 2, and then it's like x squared plus, anybody remember this from Algebra 2? Me neither. But, point being, if you can factor something and it changes it, then that'll change your limit. Like, for instance, this is an easier one. Let's say we had this problem. Watch, it'll actually be on like the next slide. As x approaches 3, this is 0 over 0. You're thinking, darn, we need to trace. But what cancels here? X minus 3, because this is the same as x minus 3, x plus 3. So if those cancel, you're left with x plus 3 only. What happens if you plug 3 into that? 6. So that would be your limit. If you can do canceling, then just do it. And that you can find your limit that way. I think there's a way to do that with number 11, but I'm not that good. Oh, I could take it out synthetically, but we're not going to do that right now. It is. But you can't just cube both. That's not legal. Okay. Here we go. Wow. Getting complicated. We plug 0 into 13. It's going to say, sorry, bro, 0 over 0. So we hit our calculator. Sorry, I'm feeling kind of, I don't know, feeling crazy. Wow, thanks for making me feel old. So here we go. 2x squared plus x, bracketed off, divided by sine of x, graph. Wow, that's ugly. Looks like a prison cell. Trace. 0 does not exist, but we already knew that. So what's the number slightly less than 0? Negative 0.00000001. Of course, what does it look like it's going to be? Before we hit enter, look at the graph. What does it look like the function's approaching at 0? It looks like it's going through the origin, doesn't it? Therefore making it 0. Let's see. Yep, okay. Anytime it gives you scientific notation, that's basically 0. Okay? So, 0. Let's try from the other side. Point. 0, 0, 0, 0, 0, 0, 0, 1. Scientific notation again. So therefore our overall limit is 0. Really? Oh, that's so sweet. I'm guessing it's a difference here. Did you remember to put your numerator in parentheses? 2x squared divided by sine. Are you in radian mode? Really? And you traced 0.0001 and it gave you 1. Weirdies. Let me look. Is anybody else getting 1? Raise your hand if you're getting 1 if you're doing this, other than the 2 of you have already told me, or the 3 of you. Job. Here we go. Is there another one of these somebody wants to see before we do 17, obviously? All right. 15 is going to do the same thing. You punch it in your calculator and you go. 17. Now, piecewise functions are where these things get interesting. Because piecewise is the only time where one might come in here, the other one might come up there. Good thing about piecewise functions are you don't have to graph anything. X less than 0 is always going to represent your left-hand limit, and x greater than 0 is always going to represent your right-hand limit. Now, for the overall limit to exist, what do you think is going to need to happen here? Exactly. For the overall limit to equal something, these two things are going to need to equal each other. So we plug in a 0, and what do you get? 1. You plug in a 0 here, what do you get? Therefore, my overall limit is 1. If they're different, then you don't speak apparently. Then it doesn't exist. Okay. We already did that one, and 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 oh, we didn't do this one. Okay. This is a step function. What this function does is basically rounds off your change. So anytime you're between two whole numbers, it rounds it down. No, it rounds it up to the next whole number. That's why, if you notice, like x equals 1.5, I was right, it rounds it down, is just 1. X equals 2.9 is just 2. This is what this function does. But just look at the graph. As x approaches positive 2, from the left-hand side, what is my limit going to equal? Austin. Very good. Very good. 1 from the left-hand side. As x approaches 2 from the right-hand side, what's my function going to equal, Caleb? Very good. Were those the same, Seamus? So what's my overall limit? And Shelby Emmons, what's my actual function value? At. Do I need to make it bigger? I'll ask somebody else. But thank you for participating. I know. Alyssa, what is my actual function value at F2? 2. Very good. Filled in dot. Last one. And dang it, let us find after this one. Never mind, we're not quite done yet. 2.5 from the left-hand side. Great. 2.5 from the left-hand side. Well, what's the y value right here? 2. In fact, let's just have somebody step up and do this whole thing. Eeny, meeny, miny, Holly. Is it continuous? I know the whole thing looks discontinuous, but at this exact spot right here, is the function continuous? Therefore, what can I conclude about all 4 of these things? They're all going to be the same. They're all going to be 2. Very good. Let's just jump straight into the last slide. Okay. This is really nothing more than everything we've already done. Punch in the value. If you get a number, yay, that's your limit. If you get something that doesn't exist, you have to graph it and trace the value. Is there any one of them on the left-hand side somebody wants to see work? 43? First thing I heard? 43. Well, what is e to the 0? Let's punch that in the calculator. clear. E, man, I don't even know where E, oh, there it is. E to the 0. It gave me a number, so that's my answer. 1. E is a physics term. It's like pi, except not. E is just a number. I don't know what it equals, though, because I've never dealt with it in my life. It doesn't even reside in my name, so I've never dealt with an E. 37, plug in -1. What do you get? There you go. Anything else on the left-hand side somebody wants to talk about? Let's go. Okay. What is sine of pi? Sine of pi. There you go. 0. Only time you're going to need to trace these things is if you punch in something like sine of... Hold on. Which one of these? Okay. If you had like tangent... Cosine. Where's cosine 0? At pi over 2. If you had something like tangent, what is the limit of tangent of pi over 2? Dang. Now I need to do my trace thing because I couldn't even get anything. Only when you get error are you actually going to have to do your trace thingy. Now, the right-hand side, the last wave of problems of the day. Just like the one Joey did a second ago. All you have to do is see if these two things are the same. Actually, I take that back. 47 is a little different. Why is 47 different than a normal piecewise? Jen, why is 47 different than a normal piecewise? Look at the other three and tell me what 47 is different. That's right. Instead of having an inequality, it has equals and does not equals. This is interesting. That's saying use this function for all x values, with the only exception being 2. And at 2, use this one. Well, question, and I would like to volunteer to answer this. When we're talking about strictly limits, do we care at all about what that exact value equals? No. This is completely irrelevant to the problem. We don't care what it equals there. That doesn't affect our limit. So plug 2 into that function, and what do you get? 3. So the limit of that function is going to be 3. All of the rest of these, you just need to make sure that these numbers, since they're all the same as the limit number, match. If they do, that's your limit. If they don't, it doesn't exist. Let's try this one. 0 plus 3 is 3. This is just 4. Does 3 equal 4? No, limit doesn't exist. Here, 1 times 2 is 2. 1 plus 1 is 2. What's my limit? 2. 0 plus 1 is 0. No, it's not. 0 plus 1 is 1. Sine of 0 is 0. Does 0 equal 1? What's my limit? Okay, let's do it. There you go. We're in the thousands. Okay. I'm done.